Hi and welcome to Trig Applications Day 4. Today we are talking about the angle of elevation and some miscellaneous problems. The first one happens to be more of a miscellaneous problem. In parallelogram ABCD, AB is 12, AD is 20, and the measure of angle A is 50. So the first thing I'm going to draw is my parallelogram A, B, C, and D. This is 50, AB is 12, and AD is 20. So that's my picture. Find the length of the longer diagonal to the nearest centimeter. Well, AC is the longer diagonal, and BC would be 20 because it's a parallelogram. So I need to find B. So I need to start and end with B. B squared is equal to A squared plus C squared minus 2AC cosine B. Angle B is 130 because those two angles need to be supplementary. So B squared is equal to 20 squared plus 12 squared minus 2 times 20 times 12 times the cosine of 130. So B squared is equal to 400 plus 144 minus 480 times the cosine of 130. So B squared is equal to 544 minus 480 times the cosine of 130. At this point, I put it into my calculator. So B squared is equal to 852.5380526. And to find B, we take the square root. So B is equal to 29.19825.427, and it says to the nearest centimeter, so B is equal to 29 centimeters. So this is part A. Part B asks us to find the area of the parallelogram. Well, the area of the parallelogram, a parallelogram has two triangles, therefore we use the 1/2 AB sine C, but since I have two of them, if I multiply it by 2, the 1/2 and the 2 cancel each other out. So in this case, K is equal to AC sine B. So A is 20 times 12 times the sine of 130. And when I do that on the calculator, I get 183.850663 to the nearest centimeter, or to the nearest square centimeter, be 184 centimeters squared. So that is the area. Alright. Number 2, from a point A at the edge of a river, the measure of the angle of elevation to the top of a tree on the opposite bank is 37 degrees. From point B, that is 50 feet from the edge of the river and in line with point A and the foot of the tree, the measure of the angle of elevation to the top of the tree is 22 degrees. Find the nearest foot the width of the river. Well, the farther you get away from something, the smaller the angle of elevation is, so that kind of helps us determine where's A and where's B. This is my tree over here. Okay, so that makes this A, and this is 37 degrees. That makes this B, because that's 22 degrees. That's the smaller angles. They've got to be farther away from the object. The distance between A and B is 50. Top of the tree is C. Bottom of the tree is D. This is a right angle. I think it might be marked in your paper, but maybe it's not. It's supposed to be marked as a right angle. And we need to find the width of the river. Well, I don't really have enough information as I see it right now, so I'm going to go in and fill in all the missing angles that I can. Since this is a right angle and all triangles add up to 180, that makes this top angle 55. And this is a straight line, so that would make this 143. And what's left over up here would be 15. All right. So I only have a measurement on the triangle on the outside, and I need to find something that they share in common so that I can use one information to find information about the other triangle. So I'm going to find that AC. So what I'm looking at is two triangles here. This is B, A and B, which is 50. This is 22. This is 143. This is still 15. And that's C. And I want to find AC. So to use my X, I'm going to have to use B and C. So it's B over sine B equals C over sine C. B is what I'm looking for over the sine of 22 equals C is 50 over the sine of 15. It's a 50. So cross multiply, and I will have X sine 15 equals 50 sine 22. Divide by the sine of 15. So X is equal to 50 times the sine of 22 divided by the sine of 15. When I put that into the calculator, I'll do 50 sine 22 equals divided by sine of 15 equals. And when I do that, I get X is equal to 72.4. Alright, so the side that they share is 72.4. So now I need to find AD. Well, so that's what I have here. And we'll call that Y, just to kind of keep them separate. So this is A, this is C, this is D. AC we found to be 72.4. Trying to find Y, I know that this angle is 37 degrees, and I know that this angle up here is 55 degrees. Since I want Y, is that 55 or 53? Sorry, this should be 53. My bad. That's a 53. Couldn't read my own writing. So I'm going to use Y and C, and then I'm going to use D and the side that we found for our triangle. So it's going to be C over sine C equals D over sine D. So C is Y over the sine of 53 equals 72.4 over the sine of 90. Cross multiply, and we'll have Y sine 90 equals 72.4 times the sine of 53. And then divide by the sine of 90. So I type that into my calculator just as I see it there. And I'll get Y equals 57.8212. And find to the nearest foot. So to the nearest foot would be 58 feet. Alright, I know you're probably wondering why in the middle of the problem when I found X, I went to 72.4 and I didn't round to the nearest foot. I always need to look at the end result, what I want. Since the last number that I needed was to the nearest foot, I always round one place past where I need to be for my final answer. Otherwise, we end up rounding too many times. So you always have to go at least one place past. If I'm the nearest foot, I have to go to the nearest tenth in the step before. Okay, that is it for the angle of elevation.